Okay, boys and girls, we're going to learn about prime and composite numbers. And this is something that we also have already learned, but it's a tricky concept. So I want to have a video prepared for you so that you could review it if you are still having trouble. Okay, a prime number. Okay, 2 is prime. 7 is prime. 11 is prime. Okay, composite numbers. 4 is composite. 21 is composite. 30 is composite. Okay, so we need to look at these numbers. Why are some of them prime and why are some of them composite? What we want to look at is the factors. Okay, what are the factors of 2? The only factors of 2 are 2 times 1. We don't have any other factors, no two other numbers that can multiply together to get 2. What about 7? Well, we have 7 times 1. Is there any other numbers that could multiply together to get 7? No, there's not. What about 11? We've got 11 times 1. All of the prime numbers only have these two factors, 1 and itself. If a number only has factors that are 1 in itself, it's called prime. Okay, numbers that have multiple factors, such as these over here. So let's think, for 4, we have 1 times 4, and we have 2 times 2, so it has multiple factors. It is more than just 1 in itself. It has another set of factors. It has 2, you can multiply 2 times 2 to get 4. So 4 is considered a composite number. For 21, we have 1 times 21. We can't multiply anything times 2, but we can take a 3 and multiply it by 7 and get 21. Okay, therefore, since we have more than just the number and the 1, since we have another set of factors, that's composite. 30, we have 1 times 30. We have 2 times 15. We have 3 times 10. Okay, we have 5 times 6. I don't need to find all these. Once I found these and knew that 30 has more factors than just 1 times itself, I can call that composite. So a composite number may just have one other set of factors, but it may have several other sets of factors also. Okay, as long as it has more than one set of factors, it's composite. So how can we figure this out? And I showed you this in the classroom because for prime and composite numbers, we can use our calculators. Okay, most of them you're going to be able to figure out on your own, but you can also use your calculator. So say you get a number like 51, and you think, well, I don't really know. That's not a usual number that I'm using with my multiplication and division. So I'm not really sure about 51. Well, you can take your calculator, plug in the number 51, divide it by 2. See if you get a whole number. If you get a whole number, that means 2 times something is 51. That automatically means it's composite. Now, like we talked about, is 51 going to be divided? Will you be able to divide by 2? No. Why? Because this is an odd. An odd number can't be divided by 2. Okay? And because there's going to be some person in this group that doesn't have a partner. So you can't divide it by 2. What if you divide it by 3? Well, if you do that on your calculator, you are going to get a whole number as an answer. And actually, it's 17. Okay, so 3 times 17 equals 51. So that means 51 is composite. Well, if 3 didn't work, you would have to go on to the next number. Plug in 51. Try divided by 4. If you get an answer on your calculator that has a decimal point in it, like I don't have a calculator right now, but say it's 14.5. No, that is not a whole number. If there's only a decimal point after the whole number, then that's okay, because that's just like 0.0. That's still a whole number. But if there's a decimal point and another digit, no, that's not a whole number. So go through divided by 4, divided by 5, divided by 6, divided by 7, divided by 8, divided by 9. If any of those gives you a whole number for an answer, then your number is composite. There are some other tricks. If you have a number that ends in any number that ends in a 0, 10, 20, 30, 40, 50, those are all what? They're all composite, because every single one of these can be divided by 10, okay? Well, actually, this 10 is not only divided by 10, but it also can be divided by 2, right? Every even number, we talked about this in class, every even number can always be divided by 2. So every even number except for 2 is going to be composite. Okay, these even numbers, 10, 20, 30, 40, 50, yeah, they can be divided by 10, but they can also be divided by 2, okay, and sometimes they can be divided by, they all can be divided by 5 also. Speaking of 5s, any number that ends in a 5, 15, 25, 35, 45, they all can be divided by what? They can be all divided by 5. If you count by 5s, you're going to land on these numbers. So that makes all of these numbers composite, because you can divide by 5. 15 would be 5 times 3. 25 would be 5 times 5. Okay, the factors. So those would be composite. I have one more little trick. Some of you will get this. Some of you might not. If you have a number like this, 51, okay, add those two digits together. 5 plus 1, what do you get? 6. That means that this number, 51, is divisible or can be divided by 3. And we already found out that it actually was. Okay, so say we have the number 7, let me see. So 51 adds up to 6. We could do 72. Okay, you add 7 plus 2 equals 9. Since 9 can be divided by 3, this must be divisible, or you must be able to divide by 3. Can you divide 72 by 3? Yes, you can. It's a composite number. It can be divided by 3. Okay, let's see, 42. Add the 4 and the 2 together, you get 6. Since it's a 6, you can divide 6 by 3. So 42 you can divide by 3. So for this 51 down here, you add the 5 and the 1, you get the 6. You can divide by 3. It's going to work even though it looks like it's a prime number.